Okay, so now we have problem number 4. So the problem says we're trying to find all the solutions to this equation. Square root of x plus 2015 equals x squared minus 2015. So the first thing that's comes to mind when I see this equation,
Square.
the square.
Get rid of the square root.
The square root is a big problem. So if I square it, I get x plus 2015 equals, let's see, x to the 4th minus 4030 x squared plus, I'll just leave it as 2015 squared. And then,
We don't know how to factor that fourth degree on top.
yeah, if you write this. This thing is a monster.
Yeah.
So this thing is a monster, and I mean, squaring this is definitely not going to work. I have absolutely no idea how to factor this. And then there's the 2015 squared.
So the first thing I think is 2015 seems not important here.
Yeah, and especially since we'll have to deal with things like 2015 squared at some point. It's probably not worth expanding that. So I'm just going to go ahead and replace 2015 by something else, maybe a. So both here and here. And maybe we can solve for x in terms of a. So this time when we square it, we get x plus a plus x to the 4th minus 2a squared plus a squared. So again, this doesn't really look very factorable when I first see it.
Yeah, because this actually doesn't change any difficulties compared to
It's really the same thing.
right?
But, I mean, if we look at it more closely,
But this one is helpful.
yeah, because maybe instead of trying to solve for x in terms of a, we could solve for a in terms of x. That seems a lot more easy to do because this is actually only a quadratic in a. The highest degree term is 2.
Can I stop you for one little second? I want to go back to your original statement here. For example, when you mentioned, okay, this is a monster, I don't know how to solve, right? I will say this, when I see every polynomials I have, I find somehow I try to make it into a quadratic. Because quadratic formula is the only thing I know, right? So at the beginning, I was saying, oh, how do I eliminate this x? Because if I don't have this x, then I kind of like having what? The quadratic. Because this is the x to the 4th, and this is x squared, and then there's no more x. It's 3 terms, right? But with this x, I know I cannot do that, right? Yeah. So now I follow what you are doing. You clearly say, okay, but this is a quadratic actually in A.
Yeah, because quadratics are things that we can deal with.
Right.
4th degree polynomials is just quite hard. So
as a quadratic in A, I think you can express A in terms of x, right?
right.
So let's write it in quadratic in A first.
C plus
X was
minus x. Right. Okay, so this looks a lot nicer. And if we use the quadratic formula,
of
we
course.
can go ahead and do that. I think just to make things easier, I'll start by looking at the discriminant on its own. So that's going to be 2x squared plus 1 squared.
Well, it should be nice because
It needs to be solvable.
Yeah,
Otherwise it's in trouble. Right?
but we can already see this is going to work out nicely because the 2x squared will give you an x to the 4th,
Yes.
4x to the 4th.
And it cancels
cancel
with
out
that.
this.
Right.
So we get 4x to the 4th plus 4x squared plus 1. And then now we subtract 4x to the 4th and add 4x. So these two will disappear.
And you have a complete square. And that's
And
exactly
This
what's
is
right.
very nice.
Right.
now you can see you're on the right track. If you
Yes.
get such things,
So that means that our quadratic formula is going to work out very nicely. And if we do it, we get a is equal to 2x squared plus 1 plus or minus the square root of this, which is 2x plus 1, all divided by 2. So that means we have two possibilities. So either a is equal to 2x squared plus 2x plus 2 over 2, which is x squared plus x plus 1, or a is equal to, we use subtraction, becomes 2x squared minus 2x over 2, which is
X squared minus x.
x squared plus x.
Now you have two equations, two quadratic equations now in x, right? So you can continue to solve them.
Yeah, so now we treat these as quadratics in x. Let's look at this one first.
Wait, our A, do you substitute back 2015 as A?
We can do that now, or we can just wait till the end and do it then. Either one works. I think I'll just wait till the end.
Okay.
So there might be something nice that comes up if we keep it as a. I think you can cancel. So if we write it as x squared plus x plus 1 minus a equals 0. And then we use a quadratic formula again. We get x equals negative 1 plus or minus the square root of 1 plus, okay, let's see, 1 minus 4 times 1 minus a, all divided by 2. Yes, and then,
Not very nice numbers anyway.
so this works out to be negative 1 plus or minus square root of 4a minus 3 divided by 2. And we can plug in 2015 and do computations to get what those are. Over here, we have x squared minus x minus a equals 0. So if we do the same thing with the quadratic formula, we get x is 1 plus or minus the square root of 1 plus 4a over 2. Nice thing is all these are real because 4a minus 3 and 1 plus 4a are positive. So that's a good sign. And we can just plug in 2015 to get the answers.
But then we still have trouble, I think, because there could be additional exaggerate answers because we squared,
Yeah,
right? This is a step to produce what? Additional answers. So how do we really know which one of those are really the answer? We still have to be very, very careful.
so the problem would occur if x squared minus a was negative, right? Because then this really wouldn't work. Although squared it would work, but the original equation would not work because squared has to be positive.
Yes.
So we can just check these solutions that come out, see which ones are less than the square root of 2015.
I see.
And so basically whenever it's a minus, it's going to be bad. But I think both of them are plus, it should work.
No, I don't think so. I think it's the one with both minuses work and the one with both pluses work. The minus is actually the one plus.
Oh, sorry, yeah.
Minus make this small. Sorry,
So
not
for
minus.
this one, it's
The different sign make it small.
right. So for this one, it would be minus basically x squared bigger.
Right.
And then for this one, it'll be plus of 1.
Yes.
Okay, and we have to check them to be sure.
You can check, for example, you basically want 4x squared is more than 4a, right?
Yeah.
So if you do this 2x over here, then you square this, you get 4x squared. So let's just quickly check on this thing, if it works or not.
So let's erase this part.
I want you to hold up a little. Okay, that's fine.
So even if you get 4 solutions, you're tempted to rush and to say that, oh, they are all.
Yeah, you have to be very, very careful.
Yeah. Okay, so we'll start with this one.
Yes.
So we have two things to look at. X is 1 plus the square root of 4a plus 1 over 2, and then 1 minus square root of 4a plus 1 over 2. So we want to make sure that x squared is,
Or 4x squared.
4x squared is at least 4a squared,
4a.
right? Or 4a, sorry.
Yes.
So in the first case, we see that it becomes,
No power, because everything is positive.
because we know that just this part squared is already good,
Yes.
and we're adding the 1, so that's great.
And you see the second one is trouble.
Yeah, because for the second one we have this root 4a plus 1 squared is just barely enough
Yeah, and
But
then you
if
have
you
to
subtract
subtract a
the
bunch
one-
of them, right?
Subtract the 1, then it's not big enough.
Their product is A, right? Because
That's another way
It's
to
another
see
good
it.
way.
The product is A, so if one of them is more than A, the other one is not.
Yeah, that's
Right?
right.
Yeah,
And then we can do a similar thing for this.
right. So this is the part you have to be very, very careful. Okay? So actually, I want to point out two things from here. It's because of this, the way actually I see this at the end, when I realized some of the rules doesn't work, I find that actually another solution for this also makes lots of sense. I think that's one of their posted standard solution. Is actually you look at this as a functional point of view. So what is this? If I graph this, let's graph that one.
So that will look
X squared minus A, right? And how do you graph this guy? What's the graph of this? Let's write it down. Y equal to square root of A, X minus A. What is the graph of this?
so
it's also parabola.
it'll be part of the parabola, but only the positive part.
Right, but what is that parabola? Now you see these two have actually close relations.
So it's actually the same parabola except flipped across.
Exactly. So basically that's another parabola, is basically the flip, right?
Yeah.
So now you draw that parabola over here too.
So now it and it should
It touches here, it touches. There are four solutions.
Yeah.
Okay. So actually you are looking for this too, right? So now you see why it takes actually the what? The greater of the bigger one. Because this is actually the higher one. And then the smaller of the what? Smaller one.
Yeah.
Right? So that's one thing to see this, why this two works. Because you want this two. Because actually the real answer you want is what? Is this two. Because this is the top half, right?
Right.
Okay. So that gives you one way of seeing why this two solution works rather than going through the algebra. But because of graphing, actually you have a much better way to solve this. Now you see actually these two functions are basically what? Nicely set. One is actually the reflection of the other one because you're swapping x and y. So that's why you know actually this solution is basically x equal to y.
right. So you just intersect x equal to y with this parabola.
Hey, so now you know one of the factors, and then you solve for the other two.
Yeah.
So that will give you another way of getting this solution. Right? And then I want to go back to the one you erased. I almost asked you to not erase. So when you get this, of course, this is we have a squared. We have a squared minus
Because 8 times 2x squared plus 1.
plus 1.
2x squared plus 1.
X plus minus x. Right? Of course, at this step you say, okay, I try quadratic formula, it definitely should work out, right? But if you do algebra a little bit quicker, you know, if you factor this, you get x cubic minus 1. Yeah. Right? And then the next thing is you factor this more, so x minus 1, x squared plus x plus 1.
Then maybe
Then you see if you do this too,
and then their sum is 2x
that's
squared.
clearly that's the factoring, right? Okay, so but that's unnecessary. If you choose this way, go with the very formal way. You don't need the extra things. You go with whatever you do with the discriminant